Welcome to the Meltzone Podcast. This is episode 60. I'm Tom.
And I'm Stefan. And on today's episode, we talk about PLA and PETG failures over time. Did you ever have a roll of PLA that you opened up just to find that it crumbled? Maybe you find out why. On other news, Formlabs launches its new and improved SLS 3D printer, the FUSE 1 Plus, which sounded interesting for me because they are talking about wasteless 3D printing, and you don't have to throw away part of the already used plastic powder, which might be nice for your economically and ecologically in the end. And then, Bambu Labs finally released their Bambu slicer saws, even before they shipped the first backer units to the Kickstarter backers, which is a good move from them.
That is great to see indeed. What I've been obsessing over is robots. DIY robots, the tools that we now have to build them, and how 3D printing could tie into that, not just for manufacturing, but also for the tools and hardware that you can build stuff from. So I nerd out about that for a while. Then we talk about E3D's ObXidian and whether it's finally going to happen. It is apparently going to happen, but do you still care? There's also a new service on the horizon. It's called STLflix, a STL subscription service. Implications to that are more than what it looks like on the surface. And also we answer a question, as we always do if you send them in through Twitter at the Meltzone, is PHA Filaments. And the all PHA from ColorFab it was, how that works out. Stefan has tried it, and he reports on how that filament is special and what it does better or worse than others. How sweaty are you today, Stefan?
Not that sweaty, to be honest. I did the ecological and even economical air conditioning, and I just vented our whole house during the night, and it's very comfortable in here currently. Okay. Just 23 degrees.
That's actually pretty good. Yeah. Poor folks in the UK sweating at like 35, 40 degrees, and they're not used to it, right? Usually they get a nice breeze from the ocean and it's just nice and cool, but yeah.
And their houses are not properly insulated, so if I vent our house through the night and even the walls cool down a bit, like the half of a meter of insulation I have around me helps getting or keeping that heat outside. But I'm doing well. I don't have any AC, but you finally have some.
Oh yeah, but I do have some in the studio here now, and it is working wonderfully. And I've already tweeted about this because of course people are going to say, AC, can't you just open the windows at night? Yes, I can. I can open the gate at night and let some fresh air in, and I do that if I'm here late. But yeah, this building is pretty well insulated. There's solar on the roof, which isn't mine, it's the landlord's. But yeah, also I guess ecologically responsible, and I'm not using it much. It's just like the little extra tip when it's just a bit uncomfortable to work, where you move and you start sweating, and just taking the edge off. Yeah. So,
and you said you set it to like 26 degrees, which is the right temperature for your shirt.
Absolutely, yeah. Maybe if I set it a bit hotter, maybe it's ironed down and just the creases come out. These are all TCL units. I have similar ones at home. You set them to 25 and it's comfortable, and you set them to 26 and it's still comfortable, but it's still a bit warmer.
Yeah.
These are.
Well, the thing is, you have
cheap and reliable.
Work in the office, and if it's just too hot, you're not efficient.
Yeah, absolutely.
So I totally understand it.
Absolutely. Before I got this thing, it was really not. I mean, I had to do like physical work, installing electrical and stuff, and it was just unbearable. So definitely worth it.
And especially compared to your basement that you used before, where you had a constant like 20 degrees.
Actually, it was quite a bit colder than that. So year round, it was like 17, 18 for the most time. which brought along with it some interesting issues. 3D printing, PLA, I mean, likes cold temperatures, sure. ABS doesn't so much. So I always had ABS in an enclosure, and I still do that here at the studio. But you can actually print ABS without an enclosure relatively well here.
Do you have the $700 Prusa?
No, I don't. I do have a Boxamo enclosure, which also isn't cheap. And I've got the enclosure from the Snapmaker, which is intended for laser cutting, but I guess it works for printing too. But the other thing is cameras overheat. I've never had that before. My A7S III, was it during I think it was during a live stream even, where all of a sudden the camera went blank, and I was like, okay, what's up now? And because I have the teleprompter, which has a sheet of black cloth in the back, just to make sure I'm not looking into a bright background and I can actually read the text. I had that over the camera. The camera was choking. So, yeah, I've never had that camera overheat, and now it did. I've already got it set to like the high temperature, but still not enough. So, yeah, it's at a certain temperature. It is just it becomes physically impossible for me to do my job. So,
yeah. It's interesting. Yeah, maybe talking about too low of a temperature. I haven't been doing like resin printing seriously for the last 2 years, but I always had the problem that when I did resin printing down in my basement, where it's also like constantly around 17 degrees Celsius, resin printing doesn't properly work at that temperature.
Yeah, the resin is too thick.
It's too thick, and the polymerization takes too long. Yeah. And I had a ceramic heating unit from Pure Poly, where I even built like a styrofoam enclosure around the machine, but it still wasn't working that well. So I hope now that like in the new studio, it's gonna be way easier.
Yeah, the thing is which is actually interesting to observe, because most stuff we use is optimized to work at normal temperatures. So like the 10 to 30 degrees maybe is like what most stuff is going to work at. And stuff like resins, yeah, they're engineered to have the correct properties at those temperatures. You could in the past see that with LCD screens, where if you have a cold screen, it's actually noticeable on the Prusa screens too, where if it's too cold, it's going to take like 5 seconds for the screen to transition from one menu to the next one, where it slowly fades in and out. Lithium batteries, right? They don't work well when they're cold. They don't work well when they're hot. They really work well at normal temperatures, and it's fascinating how much stuff depends on being run in the correct temperature.
Yeah,
we're in just a normal temperature, right?
Yeah, that's how it is. So you have now the automatic solution to keep it kind of at normal temperatures. I still need to do it the manual way. I already told you that I had 32 degrees last night in the studio, which is just unbearable. But yeah, installed like window shades this morning, and I really hope that that's gonna help me block out the direct sunlight, which is getting in there usually at night for 2, 3, 4 hours, which is just heating everything up.
Same here in the office. Speaking of heat, have you ever had PETG temper on you? Have you ever experienced that?
So I would have thought, since PETG is well, the glycol helps quite a bit, that it doesn't crystallize anymore, because PET is very crystalline and PETG makes it very amorphous. That you can't. There aren't a lot of things that change when it's getting too warm. You will reduce the internal stresses of the part, but I would not have suspected that you change its properties. But tell me more.
Okay, I just looked up the exact material. So here's the anecdote on PET. To be precise, I guess, failing on me. So when my dad and me we took our bike tour across the Alps, we had the foam months. Have I told this story before?
I have seen the pictures on Twitter years back.
Okay. So maybe I'll just go through it quickly again. We went across the Alps. I printed a phone mount where the phone just like clips in, and I mounted it to my stem cap or fork cap. I don't know what that thing is called. Just put it down there. Perfect solution. Had my sat nav, my pulse meter Bluetooth thing hooked up there. Worked amazingly. We arrived in, where did we go? Verona? No idea. Somewhere in that area, and we took we took 1 day break. We had the bike stored away, and then when we left, we loaded the bikes up on the bike rack on the back of the car. And I think just in that time of being out in the sun for like 2 or 3 hours at the back of a car on the side of the street, the parts got hot enough to temper. So the next time I tried inserting my phone into that mount, it immediately snapped. Like the wings that kind of hold in the phone immediately cracked down at the base. And it was day and night. Because like I said, it worked amazingly well the entire time, the entire trip. And then as soon as they were on that bike rack and out in the sun for a bit too long, they changed their properties from being ductile to being brittle.
Okay. Now,
the material that I printed this in was E3D Edge, if I remember correctly.
Okay.
And E3D Edge is not a PETG. I mean, it's Edge. It's a whatever brand name material, whatever they want to put in there. They're saying it is PET/copolyester blend with additives. So I don't know. I guess I should retry and recreate that. But your point with the glycol additive kind of makes sense. Yeah.
So I think there are two things. For once, I would not have suspected that you get any like recrystallization of the material due to like the more complex polymer chain due to the glycol modification. Though on the other side, PET is a very crystalline material, and one of the reasons why we usually don't, or because why there are barely any PET materials around, because it's quite hard to print depending on the conditions. You can have a part that's partly crystalline, partly amorphous, and things like that. And the crystallization, of course, makes it a bit more brittle. The question is if your E3D Edge, PET something modified, might also just have hydrolyzed. So if the heat and maybe moisture in the material or moisture just in the surrounding might have resulted in the polymer chains to break down. But
is that something that can happen without the polymer being molten down?
Yes, of course.
Okay, so
yeah.
that can...
And PETG, so PETG is I wouldn't say well known, but PETG does have the problem of hydrolyzation after you print it apart. So that can even happen after printing it and just being in a humid and maybe elevated temperature environment.
That's interesting. I mean, the way that hydrolyzation has been explained to me once was that you basically get little, this is probably very much oversimplified. You get little puffs of smoke on a microscopic level, and they physically rip apart the polymer chains, and you end up with a material that is still rigid but not strong because the chains are shorter and they don't interlock that well anymore. So what I think as a result of that is you need at least 100 degrees for that smoke puffy or steam puffiness to happen. It's kind of like popcorn.
Yeah, popcorn. Yeah. I hope I'm not wrong there, but I'm quite sure that PETG is susceptible to exactly that. And then there are, if you have a semi-crystalline material like PLA, for example, or other ones, there's also a post-crystallization behavior. So you print it apart, but it can still happen that after a while the degree of crystallinity increases, and therefore also material properties change. which can make a part become brittle over time. The question I have been asking myself for ages, and we have talked about that to Alex from Protopasta when we were at MERV 2019, why, and I think that was more a problem when we still had 3mm filament, why are there some rolls of material that just crumble apart after a while, or when you take them out of a out of their bag? I had that happen a ton to me when I still used cheap PLA filament, and especially 3mm filament, but I think I haven't seen something like that for years anymore.
The context that I know that problem from is from the BCM3D machines, from the Sigma or whatever, or the D25, I think is the newest one, because they have the spools left and right of the print platform, and then they have a reverse Bowden tube essentially going down through the base of the printer. It comes out the back of the machine, and then you have your extruders in the back, and then you have Bowden tubes that go all the way up again. And in that reverse Bowden, for the most part, that's where you're going to see filament break and crumble if you leave it in there for a while. So I think there's been some investigation by someone at some point. It's not. I'm just going off of faint memories here, but I believe some part of that was humidity in the filament as well. That plays a role in just the filament being under stress in those bent Bowden tubes, reverse Bowden tubes, plus humidity changes how the material works and how the material degrades, and it just cracks. Yeah. And I've definitely had that happen too, where you get a fresh roll of PLA, you open up the box, and it's just like, well, what am I supposed to do with these 20 centimeter long filament bits? Like, that's useless.
3D printing pen.
Yeah, sure. Resell them. Like €50 a pop. Perfect.
Yeah. But last time you remember that happening, was that with 1.75mm filament or?
Sigma is all 2.85.
So, yeah. So the thing is, I think that's partly due to material creep. And when you bend a 3mm filament by the same amount compared to a 1.75mm filament, the bending stress will be significantly higher on the 3mm filament due to the bending modulus or section modulus.
Yeah, if you bend it along the same radius, essentially. Exactly. Then you're gonna have
you introduce more stresses in the thicker materials, so they are more prone to, for example, creep failure if they are constantly under that bending load, and at some point they just snap.
And that's not something that you would. Sorry for microphones clipping here, by the way. That's not something that you. Is Skype messing with my audio settings again? Okay, the filament snapping is not something you would expect from a creep failure, because plastic creep is you would expect the material to yield over time and just to deform, but you wouldn't expect it to crack. But apparently that can happen.
Both things can happen due to material creep. There is a plastic deformation that's happening even though you are maybe not over the plastic limit, but depending on the material and everything. Is my audio now also quieter? No.
For everyone wondering, we switched to Skype for recording the video here, and Skype likes to mess with audio settings. And we've been battling this for the first couple episodes. Then we wiped everything off of the systems, and now we decided to try Skype again, and we're having issues again. Like Skype.
So the thing is, but let me turn this back up again. You see the levels, and if the levels are at the right height. So the thing is, I think both can happen, and depending on the mode the material is loaded and the height of the load in the material, both things can happen. Plastic deformation, even though you're not above the plastic limit, and also just like failure. of the material.
And in fact, the PLA failure, the spools cracking while they're still fresh or in the Sigma, that's something that happens pretty much exclusively with PLA. That failure mode has been observed, I think, since the earliest days of open source 3D printing. So the Sells Mendel, going way back here, the Sells Mendel with its triangular frame structure had those top pieces where you had the motors, the Z-axis motors mounted. They used to be mounted at the top. And they had a clamp on the side that clamped the rod, the 8mm rod for the Z-axis. And if I remember correctly, that clamp, because of the way it was designed, would snap over time if you printed it from PLA. So because that you were deforming the material, you were putting stresses on that material, you would get that yield failure at some point. And yeah, the recommendation was don't print this with PLA because it's going to snap at some point.
Okay.
It seems to have become less of an issue these days, possibly because we're using a different blend or a different grade of PLA. I don't know the exact name, but there's the PLA that was used back then is a different one that is being used now, even without additives or anything. It's just a different NatureWorks grade PLA. So that might actually have resolved that for the majority of cases.
Yeah. Interesting. Yeah. I still haven't fully finished my material creep tests, but it is definitely something you need to consider for some materials, even though from my experience, I did not have a ton of even parts under stress, PLA parts that creeped over time, if they weren't in a hot environment.
Yeah. I mean, then all all the odds are off. For PLA standing up to any sort of load.
But up to 25-30 degrees Celsius, PLA worked really well for my applications. I still have my 5 or 6 year old PLA CNC router downstairs. I still have my universal test machine I printed 5 years ago out of PLA. Still all of the parts doing fine. Yeah, nothing deformed, even though they're loaded all the time.
And PLA, I don't know where it got that bad rep, but PLA is actually one of the strongest and most rigid materials you can print with. Yes. If you don't care about heat resistance, which can be an issue if you have anything that rubs, if you generate heat there, you're going to have an issue. But if it's just static mechanical parts, PLA is a fantastic choice for that.
Yes.
All right.
Talking about different materials and different processes, let's quickly talk about Formlabs upgraded SLS 3D printer, the FUSE 1 Plus.
But before that, this episode is sponsored by Private Internet Access. Private Internet Access provides a VPN service that does two things. It adds an extra layer of encryption to all the data your computer or smartphone sends through the internet, and it masks your physical location by letting you appear as if you were browsing the internet from another country or even from any specific US state. PIA has an easy-to-use app and never collects or stores your data.
Internet security has greatly improved over the last years, meaning that hackers, government entities, or even your internet and Wi-Fi provider are having a harder time reading along or manipulating what you're seeing on the internet. Still, most of the metadata, including which sites and services that you visit and use, is still unencrypted and therefore an open book for anyone snooping in on your connection. PIA's VPN wraps all of that insecure information in a thick additional layer and tunnels it to one of their secure data centers.
Where VPN is also really useful, though, is when you want to change where your traffic originates from. Sometimes prices change depending on where you access sites from, so it's worth checking from a different location if you can get a better deal somewhere. Also, lots of content is now restricted to certain regions, but with PIA, you can appear as if you were in an entirely different region. They now have a server in each of the 50 US states and in a total of over 80 countries around the world. I hear that being able to pick a specific US state is particularly important for being able to watch sporting events there.
Yeah, so don't get locked out of your favorite broadcast or streaming service, and also add a layer or an additional layer of encryption and anonymity. And add a layer of encryption and anonymity. Anonymity, it's a hard word for me to say, but it's easy with If you want to try them at privateinternetaccess.com/themeltzone, you'll get 82% off the 3-year month. If you try them out at privateinternetaccess.com/themeltzone, you'll get 82% off and 3 months for free with a 2-year plan, coming in at only $2.11 per month. They have a 30-day money-back guarantee and 24/7 live chat support. Again, that's privateinternetaccess.com/themeltzone, and thanks to PIA for sponsoring this episode.
Wow, you'll never imagine how many tries that took us.
I know how many tries I usually need for my voiceovers, so that wasn't really that. Oh, sorry.
Thanks to Pia for sticking through this.
The Fuse One Plus, which I added to the show notes because I find SLS 3D printing, so where you melt plastic powder with a laser, very interesting, and I see a ton of applications for that process where you want to have nicer or more professionally looking parts, but don't go all the way to injection molding. So yeah. SLS 3D printing, the Fuse One got upgraded by Formlabs.
Yeah.
It now features a 30-watt laser instead of a 10-watt laser. But the thing that I found really interesting, so there are two things I would like to talk about. Usually when you're doing SLS 3D printing, your parts are totally or completely under powder all of the time, and you're just melting the material in the locations where you want to have a part in the end.
Yeah,
the problem is
you start with your powder bed, or maybe do you start with a platform that you send to your parts to? Not necessarily.
I'm not sure.
Okay.
I think you're starting with a powder bed.
Okay, so you melt down basically the first layer in that powder bed. You have a scraper that scrapes over a thin, fresh layer of powder over that part, and then the laser goes over that area again and remelts or melts parts of that fresh layer, and it fuses to the existing part. Rinse and repeat, so you always have like a consistent surface level, which means all your parts are always going to be perfectly supported, unless you get like warping and that sort of stuff. Your parts are always supported, but you always have like the full powder bed. You always use the entire volume of powder.
Yeah. So, but the problem is, so in the end, you basically take a vacuum and vacuum away all of the unsintered powder. But the problem usually with SLS processes is that you can't reuse that already used material completely. So when you're starting a new print job, you can't only add like already used material. You need to add at least like 50% of virgin material just to keep the process consistent and the material properties running well. I don't know what happens when you really just reuse powder over and over again, if the process itself doesn't work or if the parts just crumble apart. But usually in the past, you always had to add 50% virgin powder. So over time, you accumulated quite a bit of already used powder that you can't use anymore.
Yeah, and used powder in this case doesn't mean like it has been, your printed parts that would be used. No, it is just the powder that is around the parts, that has not seen any laser interaction, that has not been sintered into a part. It has just been there in a print. Yeah. So all that powder degrades. My understanding is that is because you're keeping your entire build volume and all the powder in there at a temperature like right below where it fuses. And so the entire build volume is heated, and then just that last bit of pushing it over the edge to where it actually fuses together, you add that energy with the laser. So that basically means you don't have to have a 500-watt laser in there. It's enough, or it used to be enough, to have a 10-watt laser or now a 30-watt one to just melt those parts together. Yeah. And yeah, by continuously having the powder exposed to those high temperatures just below the melting point, does degrade them.
Yeah. So in the past, Formlabs already promoted their machine that they have a more efficient process, and I think you only had to add 30 to 40% virgin powder. But with their new machine, they're saying that they can do wasteless printing and you don't have, well, you can reuse your powder over and over again, which I find really interesting. On the one hand, economically, but also ecologically, because you don't have to throw that stuff away anymore. And since the material is expensive, and I need to check the Formlabs site how much it really is, but like 1 kilo of nylon powder is usually or used to be around $150. So
yeah. And it's not that the material, like the base polymer, is expensive by itself. It is because it needs to be a very consistent granulate size or powder size for the process to work at all. I think that's also part of the problem why it degrades, is because, yeah, you keep it just below that fusion temperature, but sometimes the particles do fuse together and you end up with like an inconsistent, coarser powder. So you need to add fresh stuff.
So what you still did with the old machines and the conventional machines, and probably also the Formlabs machines, is that you sieve the material, and all of those particles that have already agglomerated, so just fused together, they are removed by the sieving process, and so there will still be at least a bit of material that you throw away in the end. But from my understanding, and I would really like to get details on that, but I unfortunately didn't really find anything on the Formlabs side. But now they're saying that all the material that goes through the sieve can be reused. And I just checked, 6 kilos of nylon powder is $1,000.
Yeah.
Oh, but that's the carbon fiber reinforced one. Sorry.
Okay.
Just the nylon 12 powder is $600 for 6 kilos. So 100 euros or $100 per kilo.
Which, as always, in a professional environment where you're saving tons of money by using an SLA printer in the first place, SLS printer in the first place, you're saving so much more than what your investment in powder costs. But at some point, it's like, hey, this is just the standard. This is how we make parts now. And of course, then you can go in and say, hey, we're not throwing away half of the powder with every print.
I find that interesting, because that's now motivates competitors to also like improve their process and reduce the amount of like wasted material, which I find very good, because 3D printing is usually promoted also that it's ecologic, because you don't like machine material away that you either throw away or have to recycle in any way. But that process, especially with a very fine like plastic powder that is already microplastics, helping to reduce that, helping to reduce the amount that you have to discard in some way, is a good step. I hope I'm right here. That's how I understood the article from Formlabs. If anyone else has any information on that, I would be really interested. But yeah, that was one thing. The other thing was, so when I saw the FUSE 1 the first time at Formlabs, at Formnext 4 or 5 years ago, it was promoted at a price tag of around of 10,000 grand. And I thought,
not
10 grand, not 10,000 grand, 10 grand. And I thought, okay, that's the end of those other cheaper SLS manufacturers like Sinterit and Sintratec, which at that time sold for around $5,000, something like in that direction. I think when the FUSE 1 finally released, it was 15 or 16 grand for the printer itself, and then you have the rework station, which is probably around another $5,000 or something like that. But now the new machine is 27, 28.
I just had the price open here.
28 grand. So $20,000 $28,000 for the printer itself. And when you purchase also all of the accessories like the depowdering station and the sieving station, it sets you back $40,000. So quite substantial. And the interesting thing I found here is that, they increased their price quite a bit. I'm asking myself if that also shifts like their target audience. But in the end, we now have more or less three price ranges of SLS 3D printers. We have the really cheap ones, cheap for SLS 3D printers like the Sintratec and Sinterit, which sell probably below $10,000 US. Then we have the Fuse, which is $30,000 to $40,000 US for the whole system. And then we have the really expensive ones, like the ones from EOS that start at $100,000 or $150,000 US and go all the way up to $500,000. The question is really, who does the Fuse one compete with? Because honestly, I mean, 30 grand for a printer, that's expensive, but given how they position themselves, and like Formlabs to me isn't a DIY maker, you're responsible for the machine approach, but it's something more along the lines of a pro machine where you have basically a guaranteed recipe of, typical slicer machine material, post-processing, that's all from one vendor, and it's like, hey, you follow our guidelines, you use our materials, you're going to have a great result, and if not, you can call us and we are going to be responsible for this, and it's not you who are going to be responsible, which is something that companies love. They don't want to be responsible for tweaking machines and stuff. So at that point, I think the Fuse is a fantastic deal. And when you brought this up before the show and you were like, hey, yeah, it was like 10 grand, I was like, are you serious? That's a fantastic deal. It used to be 10 grand. And at 30 grand, still great. I think there's still a huge market for that machine, because even at $40,000, which sounds horribly expensive for like the home gamer, for a business that can use that for either prototyping or even making like production parts, just look at all of the extruders and everything that Bondtag is making. All of those parts, they're not injection molded, they're all SLS 3D printed. I don't know if they're doing that in-house. I guess they are doing that. They have outsourced that to somebody who maybe has a higher volume.
But the parts look really great, and they work fantastically well for them.
Yeah, and for like a mid-sized production, it's very reasonable. And the reason why Formlabs always shined is, if you're staying in their ecosystem, it works quite well. And with ecosystem, I'm also talking about the software side. So like the
you're not getting much of a choice there, to be honest.
You are not getting much of a choice, but the thing is, the only choice that you're having, it comes with the machine. You don't pay any service fees or something like that, and it works. I can give, I think, preform to any of my colleagues at work, and probably even to my wife, and she is able to print parts with that, because it does everything automatically. It guides you through the process. It doesn't require a lot of training, and that is worth a ton in the end. If I just think about, for example, Materialize Magics, which might be used for other machines, which is like a professional tool for STL, so working on STL files, and for example, creating supports for different processes. The software itself is probably already around like 50 grand, and then you're paying another, it's probably not 50 grand. It's 20, 30 grand depending on the...
But it's a vendor independent software, right?
It's vendor independent, but then you also need to add a service fee on that every year. So Wartung, that's...
Which... God, I'm pouring coffee over myself. Which probably Formlabs is going to sell you as well. Just to be fair. Yeah,
they probably do. And if you're a business, you want to have a service contract.
Be right back.
Sorry.
I got to clean some coffee. You entertain the audience for a minute.
Yeah, I try to entertain the audience while you get rid of your coffee stains. So the thing is, if you are a company, it is very important for you that you usually have a service contract, because if something goes wrong with the machine, you are you don't have to take care of that yourself, and the vendor usually does that, or the service provider, and you outsource basically that risk. So, like from my experience, companies usually do that, and of course Formlabs will be doing that as well. But it's, even though it's now like 2.5 times more expensive than it used to be right in the beginning, where you were able to make pre-orders, I think it's still reasonably priced and caters to an audience that is professional but doesn't want to spend $150,000 on an EOS machine.
Yeah. Is the original Fuse still going to be available? Do you know about that?
They currently have both of them in their shop. And
okay.
I guess it does make sense that they still have both, due to the price tag. Maybe they also only just want to sell their remaining inventory. But also with the laser upgrade and everything, the cheaper version is maybe a bit slower and things like that, but it's also cheaper. So in the end, customers can choose.
Well, the biggest point to me, I think, is really the reusability. It's, do I pay a bit more upfront and then save on material as I go, because I'm going to have to throw away less of the material I buy? Or do I go with a cheaper option because I'm not going to be printing as much, because I know I will not recoup that extra cost from the material that I might save? And that is exactly what Formlabs was saying on their website, where they're comparing the Fuse and the Fuse One Plus, where they're saying, hey, the what does it say? The Fuse One Plus is a record-breaking fast SLS 3D printer for 24-hour operation, for internal 24-hour 3D printing, and the other one is just like, it's reliable. Yeah. So, yeah. Maybe lastly, how do they do the wasteless 3D printing? On the website, it kind of hints to it. It's saying they are flooding the build environment not just with air, which typically is
argon,
is being filtered. Yeah,
or nitrogen.
The Fuse One Plus is now also filling it with an inert gas.
Yeah.
So that is one of the big things with the Fuse One Plus. I could also imagine that they are lowering the heating temperature of just the entire build volume just by a bit to reduce the degradation, and they make up for that with the stronger laser. But that is just speculation.
Yeah. I don't know. It's interesting. It's not something that many of us probably have the opportunity to play with, but I'm happy to see that it does become more accessible. But I still think that this won't be something for the home gamer in the near future, just due to the fact that working with those powders is nasty. It's even nastier than working with resins, trust me.
Yeah, but
even though...
Don't underestimate. I mean, some people, I don't know, if they have some specialty use case, they might buy one of them. It's happened before with like other pro level machines.
Yeah, but then you're usually like a small business, or you have too much money.
Oh yeah, that's what I'm referring to. Yeah, those people exist.
Maybe I need to correct myself here a little bit. So also what they're doing with like their enclosed powder volume that you then put into the depowdering table, they try to minimize the waste as much as possible, and that is very important because the fine powder is nasty, and maybe it is even not that nasty as a resin 3D printing. I don't know.
It's on a different level, but in the words of a living legend, don't breathe this.
Yeah. As always.
Cool. Okay, then some good news. Or good news, or I don't know, it's neutral news. Things are happening as they should with Bambu Labs and the release of the Bambu Studio source code. There was a bit of a shitstorm with Bambu Labs not releasing their slices source code yet, even though with GPL, AGPL based code, it is based on Prusa Slicer. They are technically required to provide the source code on request to people who received the binary.
Yeah.
Which is like very narrow case, and I guess they didn't have anything public yet. When they shipped the first machines to you and others, you guys got the software, but you did not get the source code. But they have now fixed that, if too late, but they have fixed it, and they have released the entire Bambu Studio. I think that the first talks were just about, hey, we're going to release the slicer core, but they've released the entire studio thing. It's on GitHub. It is the most recent version from what I've read. It's actually a newer version than they've shipped in binaries yet. And I guess we can be happy now.
We can be more happy, yeah. So it's good that they did it, and I hope this opens up the opportunity to take some of the features that they implemented and implement them into PHA Slicer, for example. I don't know, step format support.
Right.
Which is, I think they still do triangulation at the end to for slicing, but I actually tried it out with my version of Bambu Slicer. Yeah, you can just drag and drop a step file in there, which is kind of nice.
Doesn't sound like too hard to implement. So I can see that coming to other slices as well.
Yeah, I am not sure if Super Slicer might be already supporting that, but this is something which might be cool for like people that usually work in CAD software. And too often, even if I'm at expos and see very professionally made part, sometimes people just save their STL with a 2 cores of a resolution, and you see all of the triangulation on those beautiful parts, and it just doesn't need to be that way. So
and the point that you're making with like, hey, does it really need to translate it into a triangulated mesh first before it takes the pristine step file and pushes it into the slicer? I think at some point it doesn't really matter, because unless you're implementing arcs and splines and other shapes that the printer can reproduce by itself without relying on individual points, it's, you export it or you convert it with high enough of a resolution and you're not going to be able to tell any difference.
So it also supports arcs, so G2, G3. Super Slicer has also already supporting that for quite a while.
Okay,
if I remember correctly.
Is it just reconstruction from an STL to an arc?
Yeah.
Okay.
So I'm not sure how Bambu Studio does it, but I would suspect that they are converting the step file to an STL, working with that for slicing, and then run the procedure over the already generated G code and find for segments that they can replace with a G2, G3. So your argument that, of course, just increase the resolution as much as possible is, of course, an option. The thing is, if you have a complex model and save that with a too high of a resolution, your STL file is going to be just insanely big for no real reason.
True.
Step is way more efficient in that regard.
Yeah. The problem really isn't the STL file becoming too big. The problem is the G code becoming too big and bogging down your printer firmware.
Exactly.
But we have a solution for that. It's slices now have had for a while a resolution setting where any segments smaller than, I don't know, 1/10 of a millimeter or whatever, just get stripped out and connected to the other to the one previous and next one. So
that works. But it also comes with the problem, and I have seen that on parts where I have actually tested that, is the algorithm is fine for one layer, but if the layer below, so the merging, doesn't match up with the merging that you did on the layer above, you can see slight layer changes.
So it's
layer changes or shifts.
It's different faceting on each layer where the segments meet. And if you set the resolution setting really low or really coarse, then that can be an issue. But if it's just at a level where the printer can still keep up, you're not going to have an issue.
No, and with like more recent control boards, that is not that much of a problem anymore. I don't know. So you currently did the how's it called, Fiberpunk thing. So with remote hosts, it's probably going to be interesting, because I know that when I used shitty USB cables on my Octoprint, it had problems streaming the G code to the printer. And now you could say, yeah, firmware is totally fine, but if you're working with these remote hosts, maybe small movements might become a problem again, because the bottleneck might be the USB connection again, or the maybe USB to serial converter on the main board.
Yeah, it's always the serial connection in that case, which is why the Fiberpunk uses a SD card dummy, and it doesn't actually stream any G code through USB. It has an SD card in here, and it basically feeds that straight to the printer. It takes the SD card from the printer when it wants to write files to it, and then when you start a print, it gives that SD card back to the printer, and all it does through USB is say, hey, print this file from the SD card.
Okay.
That's all it does. And I think that is a solution that works is on the performance side. But of course, there are some implications, like not being able to upload G codes while the printer is doing something, because then the SD card is like physically attached to the printer, and you can't have two hosts writing to the same card.
Yeah, interesting. So
yeah, it's workarounds for that exact problem, right? Not having enough bandwidth to transfer like really fine G code. Internally, if you have G2, G3 arcs in G code, if I remember correctly, those just get translated to segments as well. That is a setting in Marlin where you can set how fine that becomes, but the firmware does it. It's not every ARC segment needing to be transferred through USB or on an SD card.
Well, you have a stepper motor. Stepper motor already means that you need to do discretization in some way.
Right.
But yeah.
Right. Yeah. So cool. Good that that's released. Arcs, etc. It's always nice to see stuff released. It's always nice to see code build on other code. And then eventually we're just going to see everything melt back together into one big engine. Like I think Cura also had that once, right? Where it was like two different branches, and then I might be mixing up things here. Okay. Anyways, moving on.
Moving on, but staying at kinematics and main boards and things like that. You were thinking about building a robot arm.
Yes, so that was one of the things that I played with the idea once I got the studio here, or actually before I got the studio here. I wanted to build some sort of robotic camera system. And in the old studio, because it was a basement room, I was just gonna have like a rope. My frame is too small. A robot wall, basically, where it had like large Z-axis and X-axis, and then like some slider that can come out, that can kind of work its way into my set and kind of get all the different camera angles. Problem is that the ceiling here is 6 meters tall, so I can't really do that. So I've been looking into like industrial robot arms and stuff. And quick side note here, why this kind of kicked off and why I've been obsessing with robot arms and cycloidal gearboxes and kinematics. Elephant Robotics reached out to me. They're Chinese robot company. They make the My Cobot, My Palletizer, which are like very light duty robot arms. They were like, hey, can we work together? And I was like, yeah, I mean, I've got an application for like putting a camera on it, putting a 3D printing tool head on it. Do we have anything that could work for that, where we have like 300, 400 grams of payload and maybe like a medium range of motion and all that? And they were like, yeah, cool. We can send you the MyCobot 320, which is a 1 kilogram payload and I think 600, 500 millimeters, somewhere like in a medium work range thing. And I was like, yeah, sounds cool. It has Python support, and you can do all sorts of easy stuff with it, and it don't need to learn whole new industrial control units. Looks good. And they were like, okay, we're going to send you the MyCobot 280. I was like, hold on, that's not what we talked about. And if we look at the 280, it is literally like 6 RC servos and a Raspberry Pi and a couple injection molded parts. And by the way, YouTube channel recommendation, Scientific, fantastic channel. He has a video on that robot, and you can just see like it's exactly what you'd imagine 6 RC servos doing. You have a move command, and it's like and it bounces around, and it has a 250 gram payload. Though honestly, if you put any weight on it, you can see like you put like 100 grams on it, and it sags by 5 centimeters. Yeah. They charge $700 for that thing.
Okay,
$700 for a couple RC servers and a Raspberry Pi, which is obscene. So I was like, no, sorry, I can't work with that. I'm like, so after that, I've just been looking into, I mean, Scientific, like, again, fantastic resource on just robot actuators that you can get ready-made. But the thing is so robot joints essentially have the requirement of being rigid and high torque. And then, of course, if you want like stuff that can like take your head off, you also want it to be fast. But I don't care for that too much. I would rather have a robot that is kind of slow. So the requirement is lots of torque, rigidity, which means you need a gearbox. You need something to gear down torque from a motor, which typically spins fast and has little torque, to something that spins more slowly and has lots of torque. That's what a gearbox does. And one of the cool ones is cycloidal gearboxes. James Bruton has been building those for a while. They look extremely cool. They work really well. And maybe that's just something that I can try out and just go step by step. Say, hey, let's build a cycloidal gearbox. Let's go through the engineering process, because you can build them a lot better than what James does. Not that I want to discredit him here, but you can optimize them for 3D printing a lot better. And just see if I can make an actuator here. And the cool thing is, it's not that it would end there, because with the tools we have from 3D printing today, you can go a lot further than just building a single gearbox. RepRap Firma, Do It 3D, is now implementing robot kinematics, which is fantastic. So one of the core things with robot arms is that, yeah, you can control each motor individually, but like depending on how your axes are rotated, your tool head is going to move different amounts. Like, you know, so you need to do reverse or inverse kinematics, which is a whole section for itself. And RepRap Firmware apparently is able to do that at some point, where you just say, hey, this is how my robot arm is built, and please move the effector to this position at that rotation, and it just like does it. So I'm just fascinated by how much this stuff has progressed, how accessible it is. Yeah, Do It even has a motor driver board that has an encoder support and brake support, which is exactly what you need for robot arms. Yeah. I could stay within the 3D printing ecosystem. Use NEMA 17, NEMA 23 steppers, use Do It 3D, RepRap Firmware, use something I know, and build a robot that, two goals, at least is going to be fast and accurate enough to do some 3D printing, maybe not with a 0.4 nozzle, maybe with a 0.8, and also is smooth enough to carry a camera, especially for live streams or for time lapses, doing like crazy 3D time lapses around the machine. Like, it's just a whole new world that I've been diving into the last couple of days, and I enjoy that. I enjoy that a lot. Just learning about new stuff, learning what's possible, and learning how things click together.
Yeah. So when I last time dove a little bit deeper into robotics, when I don't know, somehow watched a couple of MKBHD videos, who also have their camera robot, and they're doing those really beautiful shots with that. And I also thought about, what's available in that direction that is accessible for me, and would that be an option to make really beautiful shots with it? Probably a bit overkill, but just the precision and the beauty of the moves of a robot arm is just amazing. And even professional ones are not that expensive anymore. If you're taking a look at what a cheap KUKA arm or from one of the even cheaper knockoff brands cost, they are not that expensive anymore. So they're getting more expensive. Of course, controlling them is probably not the easiest thing, but in the end, it's doable. So
the big challenge with the KUKA arms is safety, because they will kill you. Literally, if you're in the wrong spot and run the wrong command, they will completely smash you to pieces, and there's no escape. So typically those KUKA arms that you can get for, I've looked into those too. You can get them for like $1,000 or $2,000 if you get like one from the 80s. You have to pick it up from Hungary, but okay. Those don't have any safety features, so they are intended to be run in like a complete cage with a laser curtain or some way of safety where as soon as you get near the robot, it shuts off.
Yeah.
So that is the big downside to those. They don't have any sensing for how much force they're pushing at the time. So I guess the camera robots that you see, they're being used in a very controlled environment. I'm not sure if I'm up for that, if I want to take that level of responsibility for me and for whoever else might be near the robot. So what you really need is a cobot, and that is those robots that have force sensing on the joints or even load cells in the connection pieces that can force how much force that can sense how much force you're putting on the effector at any point, and it's just going to stop or reduce its speed. And those are a bit newer, those are a bit more expensive, and you typically don't get them with like significant payloads. Like I don't think I could put my A7S3 on it because that thing weighs 2 kilograms with everything. Because 2 kilograms of force, like, are you going to detect the difference between like the dynamic forces of acceleration plus the weight of the camera versus somebody's arm getting sheared off? That becomes a very thin line there. So yeah,
cool project. I would really enjoy watching that process, and especially if you're gonna do the engineering on the critical parts.
Yeah, it's that there are robotic arms out there, but they are engineered for slightly different use cases than what I'd be going for.
Do you know the YouTube channel from Jeremy Fielding?
Yes.
Yeah. So he also recently built one. He's the for anyone who doesn't know him, he is one of the I guess engineers that works together with Destin from Smarter Every Day, and for example built his the pressurized air cannon. So
I did not know that.
That's how I got to know Jeremy.
I just saw his videos on my Twitter feed and was like, that looks like cool stuff that he's doing there. Yeah, so he built one, but that I think he's doing like industrial welding with that, and a bit overkill for what I'm trying to do. Really, all I need is, if you say we're engineering for 500 grams worth of payload, I can put a ZV-1 on there. I can put a Hemera or a Bondtech, whatever, on there, and it's gonna print. And I want it to be rigid. I think that's gonna be the biggest challenge if I 3D print gearboxes. Not having backlash, I think I can tune out by just changing tolerances. But rigidity, plastic flexes, right? So we're gonna see. I'm just playing with the thought right now, and I'm looking at what's possible here, and I'm finding pieces that would work.
Cool.
So as far as 3D printing toolheads go, moving one step down on the toolhead chain, E3D's ObXidian nozzles. It looks like they are finally, let's just say it looks like they finally exist. So the bullet point I put in here is, do you still care about E3D's eternal ObXidian teases? Because to me, it feels like they've been teasing ObXidian for so long. What's it called? Revo. Revo's been announced in September of 2021, and like now, 10 months later, we finally get the ObXidian nozzles that I, as far as I believe, have been promised from day one. where it was like, hey, yeah, right now we only have the brass nozzles. I know that's a drawback, but we're working on something that's going to get rid of that drawback. So the question is, like, could they have? Because honestly, I'm kind of tired of seeing ObXidian teases. I'm tired of seeing it like announced and like not existing. And I'm just like, okay, come on, just take a step back. Say we're having some delays. It's gonna be there eventually. Give us a timeline, but don't be like, hey, this thing is right around the corner. This thing is right. It's gonna happen. I promise. It's gonna be there. What's your position on that?
Yeah, well, so we both made videos on that, and one of the biggest complaints from many viewers was, yeah, this is not an option for me at the moment because there aren't any abrasion resistant nozzles, because people seem to use them quite a bit.
Well, I don't think it's that they use them, it's just that they would like to have the option to use them.
Exactly. And when they add a Revo on their printer, there aren't any third-party nozzles, so they're stuck with that. So this printer ain't gonna work for abrasive materials. So they kind of had to make sure that people realize that abrasion-resistant nozzles are still a thing and they're gonna be there at some point. But I feel with you that it became annoying after a while.
Well,
I already told. No.
It's blue ball symptom. Like you get teased for so long, and at some point it's just like, come on, I don't care anymore. I know it's gonna happen, but like the excitement is over.
So I was really looking forward to seeing the nozzles with my own eyes at MRF, but the problem was that the whole booth from E3D was stuck at customs.
Yeah.
So they did not have anything from the not released things at MRF.
Did Repcore not bring anything?
Only released stuff. But
okay.
They weren't able, so as far as I know. So they were asking people from the community about, hey, do you have a Hemera installed on your printer? Can we borrow that for the weekend and things like that? So yeah. So I was kind of upset, but I talked to the guys and I don't know. So the thing is, they wrote me last week that they are sending out hopefully review units or finished units, and they are hopefully about to release them. And they told me that I gonna have my set of ObXidian this week, but if that's true, I don't know. If that's final hardware, I hope. And yeah, at least they told me that they wanted to release it now in summer, and that they are even working on high flow for hopefully shortly after that. But yeah, so far, if they're not having them in store, it's just a mystery.
Yeah. And I unfortunately don't have any inside scoop that I could share about these. So I mean, they've just recently shipped the first set of ObXidians. That's what they've shown on Twitter. They've shipped it to, I believe, a customer.
Okay. Oh yes.
Yeah. So I think they're ready to ship soon, but
hopefully.
That's been the implication, or that's been applied for the last month. So, yeah. Okay, but apparently, this time for real, it's gonna happen. I swear. It's pinky promise.
Pinky promise. Cool. Last topic: STL subscription. You dug that out. I haven't heard. I had never heard from them so far.
Yeah, me neither. So this was just something that flew across my timeline. STLflix. STLflix, obvious play on Netflix, which is a company where you can borrow VHS tapes over the weekend. You pay a subscription fee, and you always get like you can get different subscriptions where you can borrow 1 or 2 VHSs. You turn it, you can pick up a new one. Or did I miss something there for the last decade?
Digital now.
Oh right. Yeah, they do DVDs now. They
come
ship
over
them to
your phone line.
Really? I thought
honestly
you order them and then you send back the DVDs. You don't have to go to the store anymore.
Yeah, I still remember the time when, was that over Amazon or was that already? Yeah, when Amazon was still sending out like movie rentals.
Did they have rentals at some point?
Yes,
I do
they
not
did.
know about that.
They did. So that was probably like 15, 20 years ago.
Do you remember when Amazon was still selling books?
Yes, I do. I think I checked recently. I think I ordered my first book on Amazon 22 years ago or something like that.
Has it been that long? Wow.
Yes, it has.
Yeah, okay, kids. Here you can see the two grandpas reminiscing about the old times when the internet was still new. Okay.
Anyways, what's STLflix?
So apparently, I mean, I've not seen more than anyone else has. STLflix is a platform that intends to sell you a subscription to download STL files, high quality, curated. I don't know if it's curated or if it's exclusive models that are designed for that platform. It looks like they've got a mix of everything in here. So I'm seeing some flexible dragons. I'm seeing some high detailed sculpts and busts. But basically, it is, the idea is $9.90 a month for personal use, or $19.90 a month if you want to sell prints. Which that is a killer deal. $20 a month for like unlimited selling of parts. That makes print farms worth it. But yeah, it's a subscription where, as far as I understand it, you can download as much as you want. You can access the entire library. You can download the parts. You can print them. And my understanding of that would be, some of the monthly membership fee goes to the creators of that, whether it is through like a fixed deal where they contract designers, where it's like, hey, can you design 5 parts for us? We're going to pay you X amount, or through a part of that fee. But yeah, it's a way to not have to purchase or subscribe to individual designers to get their designs, their higher quality designs, but to just have like a scattergun approach where it's just like, here's $10, give me something. Yeah, and you had a cool point about that being a viable way to support designers, right? Or did you not?
I don't know if I already forgot that, but so maybe you can help me out there in a bit. So the thing I find interesting about that is, I think that can only work if that subscription fee is worth the $10 that you're spending. So you need designers that can do those 3D models, and many of the popular designers like Wexter and all of the other ones, Chaos Cortec, many of their models had been on Patreon before. So I don't know if such a service can really work until you have like big names on that platform, and probably even exclusively. And that would be a big step for a creator to say, okay, I'm not like distributing my models over Patreon anymore. I basically kill my Patreon, and now you guys can get all of my models on STLflix or something like that. I mean, currently the model is like you said, Patreon, or some designers also have a shop set up where you can buy the what's the Deadpool bust? Yes.
Yeah, exactly. Where you can buy models from him, which are super high detail, and they're like $3 or $5 for per piece. So you buy those individually, or going through Etsy, etc. The alternative, of course, is through Patreon, but Patreon doesn't have that shop system where we're saying, hey, I want to buy this model, and you pay you $5 once, and that's over with. Patreon already is sort of a subscription service to a designer, right?
Yeah.
But of course, the issue that Patreon is running into is that people see a model, they want that model, they don't have a way to buy that model, so they subscribe and they immediately cancel. I think there's now been like a bit of a change in Patreon's terms where, it lets you set the option to immediately charge them for the month, because typically you'd get immediately access to all the files, and you could cancel and you wouldn't spend anything. So they've now gotten rid of that. But what if you just want, or what if somebody just wants access to the entire library, subscribes for a month, downloads everything, and is like, thank you for that, goodbye. That's kind of that's something that's going to be an issue once the library grows larger. And I've seen similar approaches with story blocks, formerly audio blocks and video blocks. They had the exact same model where you have a library of stock footage or stock images, video, audio, and you had a monthly fee. You could download as up to a reasonable limit, as much as you wanted, and then you could use those files forever, actually. So what they also did was like, hey, we're going to impose some reasonable download limits. And I think it's like 10 downloads a day for them now, somewhere in that neighborhood. The question is that something that STLflix would have to impose as well, where it's not you get a full flat rate for $10, but it's, you get 15 downloads a month for $10. Similar to like stock footage sites now have like credit systems where you have a subscription and you get a fixed amount of credits.
This might definitely be an option, but that might put some off. The other way to do it is just to feed that subscription service like month per month with interesting models. And this should be the way to go. True,
but why would you want to subscribe continuously then? Why wouldn't I just, get 1 month now, download everything, wait 6 months, then get another month? There needs to be some incentive.
Because people are impatient. Because in 6 months' time, the articulated dragon is not the big hip thing anymore. Then it's the, articulated elephant, or
true.
Who knows? So you do have the incentive to add interesting and new models every month that people are staying with the service, that they can print the models as soon as they come out and as soon as they are interesting and as soon as they see them on their favorite, social media channel. So I think something like that can work, but I don't know if that's going to work if those models are all from unknown names, even though they might be good. I don't know. And
so you're saying that there needs to be a hype behind the models.
Exactly. So they probably will have to spend a ton of ad money to make them popular, kind of in a similar way as I think Thanks did and is still kind of doing, to establish their brand with lots of features on popular channels and things like that. But otherwise, it's going to be a hard business.
Yeah, it only works at scale. It doesn't work if you just have 10 subscribers and have to pay 50 designers. That doesn't work out.
Yeah.
I mean,
and the question is, maybe one last thing. I'm currently just seeing like an org model on that website. You can't just contract a sculpting designer on Fiverr and tell him, okay, I want a model of an org. No, that model also needs to be nicely 3D printable. So you need to have designers that do have experience with additive manufacturing.
Where have you seen that before? It was some platform that had a similar model where it's like, hey, we have all these high quality designs, but half of them were not optimized for printing.
Well, that's, I think, kind of a problem with if you compare GrabCAD to my Mini Factory, for example, my Mini Factory says all of our models are 3D printable. GrabCAD has a huge library of super detailed parts and assemblies, but their primary goal is not the additive manufacturing community or 3D printing community, but you can download a ton of good models there, but they're not optimized for that process. And I think it's going to be the same thing here. If you have somebody that can do great sculpts of models, but you need a ton of support, that's the thing why the models by Wexler, Eastman, and all of the other guys, Chaos Cortex,
Eastman. That's the Deadpool.
Why they are so good. They are not only looking nice, but they're 3D printable without support structure.
Yeah. So really, I think the value in services like this, to me, would be being able to support the designers of the models that you actually print. So I don't know, if I keep printing the models from one person and I really like those, and just having this like low effort, low barrier, automated way where it's like, hey, I download this and they get the majority of my subscription fee. That would be cool if it works that way.
That's always the big discussion with things like Spotify, for example, because Spotify works like that. You spend your $10 and all of the money from everyone gets into a big pot, and then at the end of the month they are paying that out. Just if somebody has a million listens, they get way more than just someone who has 10 listens. But if you are a person who's just listening to that person with 10 listens, your money is still getting distributed to the artists that you don't even listen to. And something like that would be interesting for such a service right here, because if you would say,
figure that out?
But that's easy for everyone. So for example, if you subscribe to the service, every month they are tracking which models you are downloading, and then they distribute your share that they're paying out to creators under the creators that made the models that you downloaded.
Yeah, but so if you what you were saying with Spotify, I think that does work as intended. Sure, your money gets distributed to everyone else too, but by listening to that one artist, like proportionally, everyone else's money also goes to them. So that does work out. The thing with 3D printing though is you're not downloading the model every time you want to print it. You download it once, and then you might have it sitting on your hard drive and you print 5,000 copies of it. But somebody else has like 10 varieties of a model, and you download all 10, and then they get like 91% of your revenue, and the one artist that he printed 5,000 times only gets 9%. So it's having that sort of tracking really for models where it's a fair distribution. That's tough. I don't know, maybe you could integrate it with a slicer and just say, hey, this slicer kind of has the backbone to the service and just monitors what you're printing. But then again, G-codes, it's tough. Being fair is tough. Moving on from that, the other thing that I'm thinking about is like, hey, as a user, do you want to have to pay or to have to subscribe to like tons of different artists and juggle that, being like, hey, I'm subscribing to this guy, but I also want to print from this, but now I'm like racking up $50 worth of subscriptions every month. Having a way to kind of distribute a fixed amount of like, hey, I want to print stuff, I want to get cool models, and I want the platform to decide who I'm distributing that to. I think that can really lower the barrier of entry to paying for models. Especially compared to individual subscriptions, maybe one-time purchases are easier for that.
But I think such a system can only work if you have a ton of subscribers, because otherwise you don't have enough revenue that you can distribute under the other creators. So it's gonna be interesting.
Yeah,
we'll see. And I think they haven't shared any release time or something like that yet.
STLflix.
STLflix.
So they're saying they have weekly launches, a new drop every week with multiple different models. So at least 2 per week.
Yeah. Did they already launch?
They're live, yeah.
Ah, they're live.
You can subscribe to them. I think you can even browse the model library.
Okay.
Yeah, they have articulated models. They have these look like knockoffs of the actual, what's it called, dragon thingy. Home decor collections, tech looking prints, statues. They've got a couple models yet, and they've got a coming soon section with chess sets.
Ooh.
Viking, orc, dwarf, Japanese, elf, and Greek themes. So yeah, I guess right now you can subscribe to them. I tried finding the actual license text because especially if you're saying, hey, we have a license to sell physical prints, that really depends on the fine print, how much that is worth, whether that's like a perpetual license or just during the time of while the subscription is active, or sell, what does that mean? It would have been nice to find that, but I've not found that yet. But yeah, they are live. You can subscribe to that.
Okay.
Right now.
That's cool. So maybe we have subscribers under the listeners. So if anyone checked that out yet, please let us know.
Yeah. And okay, let's finish this out with one question from the community that is on YouTube, I believe.
Yep.
From Super Smash Sam, asking about PHA filaments. Have you tried, or do you plan to try PHA filaments? It's a biopolymer made from bacterial fermentation that has only recently been gaining a lot of attention. PHA filaments are starting to be easily sourceable and affordable. Its main appeal is to be biodegradable. So the question is it easy to print? Does it have good mechanical properties? And if so, it could be a more environmentally friendly option than other plastics. And Stefan, you have actually tried it, and I have too, in a way, but not in its pure form.
Yeah. So currently I am aware of 2 vendors that sell PHA. So like more or less pure PHA filament, and that is ColorFab with their all PHA filament, and there is Regen, which is I think only sold at a Canadian filament reseller, filaments.ca. And they're also claiming that this is pure PHA filament and different to what we have seen on the market. So from my experience, it is more challenging to print than as with PLA. It has a bit of a warping tendency. Sometimes it flows interestingly, but so far the material is... wait, I have a part right here.
Yeah, so that's the new pure PHA. What we used to have is actually a PLA PHA blend. So we've kind of been printing with PLA PHA for a while. That has been ColorFab that has been making PLA PHA blends, but not pure, just as a mix.
So the reason why they added PHA to the PLA filament is just to make it less brittle. And the reason why they didn't make any pure PHA filament, because PHA is also semi-crystalline material, likes to crystallize out during printing, which causes warping and everything, but also has a really nasty post-crystallization behavior. So if you just leave the part sitting somewhere for a week, it will get brittle over time and just fall apart.
Okay.
So I guess they had to at first solve the challenge of post-crystallization to get that under control, that the parts don't crystallize out over time. I think even the glass transition temperature of PHA is below 0 degrees Celsius, so you always have this
Right.
the possibility that something like that can happen. But ColorFab and obviously also like Regen, they seem to have solved that problem. Yeah, this is a print of myself printed with the ColorFab PHA filament. As I said, it is not the hardest to print, it's not the easiest to print, but it does have kind of a nice texture and feeling to it. At first I thought it feels quite a bit like a hard TPU, and the filament itself feels really soft, but in its printed form it feels very similar to something like an ABS, but it doesn't smell, it doesn't need a heated print platform. It has a bit of a warping tendency, and it does biodegrade. You can I can link that below right here. I did some composting tests with the PHA filament after my last composting test, and that stuff really was almost gone after 4 weeks on my compost pile, and not just like breaking apart. You could really see that it was eaten by bacteria and things like that.
All right, so that's actually one of the big claims. I'm just trying to find the data sheet of the all PHA, which I have, but I need a comparable PLA that I want to compare this to. And thankfully, ColorFab do have the full data sheets here. He's sending me stuff.
Yeah, I think it has a Young's modulus of 2100 per their data sheet, which is in the range of PETG and ABS. Tensile strength is nice. It does have a really nice layer adhesion. I would not have thought that, because often these, engineered materials and being good for a certain application materials, they have bad layer adhesion. But even though I didn't tune anything right here, and it's printed at 190 degrees Celsius, that thing holds together quite well.
Yeah. So looking at the Stefan, I think the WhatsApp message went to me just now.
Oh shit!
Sorry, podcast listeners. If you thought you got a WhatsApp message there, looking at the data sheet of pure all PHA, pure PHA, and their PLA PHA, both from ColorFab, so the values should be comparable. The pure PHA is a much weaker material, so yield strength and tensile strength both are significantly lower, about a third less to 50% less than the PLA PHA blend. The modulus of elasticity, so how rigid the material is also a bit lower, so it's a bit softer. But it's not significant. It's not like a full flexible material. It's more along the lines of just, PETG, ABS, somewhere in that neighborhood. Interestingly, heat deflection temperature, 153 degrees for PHA.
Okay.
So that is pretty good. It is not listed for their PLA PHA.
But it's probably around 60 degrees Celsius.
Yeah, so in that regard, it is pretty good.
Yeah.
Anything else I'm seeing? Yeah, go ahead.
One of the big problems with the material is that at least the one from ColorFab is quite expensive. It's $50 for a 750 gram spool. The Regen material, that was quite cheap. I bought the roll for 28 euros for 750 grams. Shipping, import taxes, and UPS fees, I think now made it cost me 100 euros per spool. But anyways, I just wanted to try it out. So the problem is PHA has a very small market share at the moment. It's just in the range of, 2-3% of all of the biomaterials.
And most of that is probably in a mix of PLA PHA.
maybe, or different applications. So it's way more expensive. And in order to tune the properties, you need to modify the material. And that modification process, that compounding process, of course, again, costs. So it all ends up in a more expensive material. I wouldn't say that this material is perfect at the moment. And especially if I have big parts, they tend to warp on the building platform and sometimes don't stick, and sometimes it's sticking way too well.
But it doesn't need to be, right? It doesn't need to be like the perfect material, because we have other materials that do that job.
And it's the first. So I want to promote that material for the reason that I find that it is a step in the right direction. I read a ton of papers and write-ups on PHA filament, and it's, especially compared to PLA, a material that is really biodegradable. It is really home compostable. It biodegrades also very quickly in the sea, in sweet water. What's in
regular sweet water
in your
rivers,
pond next door. So, and if you're not using additives that are harmful and things like that, it just breaks down to biomass. So
fat cells. So this is basically oil lipids that this is based on. PLA is more of a sugary material as far as I understand it. But yeah, it's like I said, it doesn't need to be perfect. It is a material with with one very specific property, and we need those materials. We have so many that are like one-trick ponies, but it's good that they are one-trick ponies, because you have applications that have different jobs. What I would be interested in is how much does the PLA break down in regular use? Like if you have parts that you touch with your fingers, you're always going to introduce new bacterial cultures to that material. Is that going to eventually just going to fall apart or abrade or leave you with like a greasy layer that's like half composted on the surface? That would be really interesting. Otherwise, like if it can't do that, if it can't be something that you can handle and use regularly, is maybe there's some other stuff where you can use it, or you just use it on internal parts that are not going to see a lot of use, a lot of fingery attention. But
I guess that is the big challenge with polymers. So if you have packing material, you want that packing material to be blocking oxygen from the outside. You don't want that the packing itself falls apart while for example, food is still on the inside. On the other hand, you want materials that maybe do biodegrade after a while, but how can you, trigger a material of now you can start degenerating and you're not in use anymore. PHA can be a replacement maybe for a lot of applications, but there are still applications in the end where this is not the right material, because you maybe want to use it in an environment where you have the bacteria and things that can break that thing apart. But if this material becomes more and more popular, I could see it as an alternative, and an alternative that doesn't do as much greenwashing as PLA, for example, does. So
I was going to say, like, hey, if you now produce plastics, polymers, PHA, it's still a polymer, but it's like eco-based and recyclable, that is designed to be thrown away, that is designed to have an end of life that literally is garbage. Is that really better than a plastic that is getting recycled? But then again, the point is, like, plastic isn't really getting recycled. That's really
exactly
that is the greenwashing point there. Even if it has like all the fancy recycling symbols on there, and we have the Grüne Punkt collection systems and stuff, most of it is getting burned. if we're being honest here, the only thing that is really getting recycled is like maybe plastic bottles, because those are very pure PET. But everything else just goes to waste.
To be honest, I also wouldn't recommend that, throw all your 3D prints on your compost or on your, I don't know, in your garden, and let it break down. But the beauty of this material is that if it, for any reason whatsoever, it ends up either in in nature or even in a landfill, it will break down quite quickly and will not leave you with harmful substances in the end. So it is, I wouldn't say a solution to the microplastic problem, but since it doesn't produce any microplastics, it's an alternative that doesn't do that. And it won't be there after 1,000 years on a landfill.
Yeah.
So, yeah, it is not a perfect solution, but I would really like to see more development in that direction to bring the prices down and maybe to even tune the properties in a better way. You just said in the beginning, like the first PLA filaments that you used, they probably did not have the performance level as our PLAs have nowadays. But the reason why there was development is because it was used a ton and there was a necessity to make a better material and a better usable material. This is a start. This is Colorfab's first PHA material. This is Regen's first PHA material. And if users buy the material and use it for certain applications and give feedback what works and works not, and they do have the cash flow and the interest in the material, I'm sure we'll see more of that. And it's a really promising candidate. As I said, the parts feel good.
Yeah. Like I said, alternatives always good. Choice is always good. It's the same thought as with the Formlabs FUSE 1 that we talked about earlier. More choice is usually good for the customer. So
yes,
it's nice that we have it. So thumbs up to Colorfab for bringing this to the market, and to who was the other one?
Regen
for also doing that. Unless like PHA turns out to be like a material that releases 2 tons of methane for producing 1 kilogram of filament. I hope it doesn't, but
no, as I said, PHA is not a material that is new on the market. It has been used for decades, but just not in 3D printing. So
yeah.
Cool. So that's it for today.
Yeah.
If you guys have any questions for the next episode of the podcast, which hopefully will release in 2 weeks of time, then put them down in the comments, tweet to us at the Meltzone, or even write us an email.
Do we have an email address listed? I think we do on the website somewhere.
Yeah. You're going to find a way to contact us. But YouTube comments are usually the best thing to get in touch with us. If you want to support us, there are individual links to our Patrons down in the description. And thanks for your time. And we hope to see you in the next one.
Thank you for your time, Stefan. And goodbye.
Bye-bye.